Right, in this video I'm going to have a look at various situations where we're going to use the chain rule with some standard derivatives as a combination. Very straightforward questions and very commonly asked in the Year 13 exam. So if I look at question number 1. Okay, question number 1. Let's say we've got a curve y equals the sine of 2x this time. Now notice what we've got here can be classically described as a function of a function. This is the easy way to spot the chain rule in action. Because what you've got is a function of x, 2x, that's a function of x, and it's being acted on by a sine function. So you've got a sine of a 2x. Sine function acting on another function 2x. So classically we'd call this a function of a function. And this is the easy way to spot the chain rule in action. So what I'm going to do is use the formal way of doing the chain rule for this question. What I'm going to say is let u equals. Now in previous examples, if we had something like y equals 2x plus 1 to a power 4, the thing inside the bracket we called letter u, and the power 4 acted upon that 2x plus 1, which was the u. In this particular case, it's the 2x that we call u. And likewise, as we've done in the past, we're going to need du by dx when we use the chain rule. Du by dx would be 2. And if u is equal to 2x, then we can also say that y, therefore, is equal to the sine of u. And if you remember, for the chain rule, we need to know what dy by du will be equal to. So we differentiate this with respect to u, and if you learn the result, standard result, differentiating sine u, you get cos u. We now take the formal definition of the chain rule, which is dy by dx equals dy by du times du by dx. Okay, and once we've got that in place, we substitute in the two things we need. Dy by du is cos of u, and we multiply it by du by dx, which is 2. So you end up simplifying it to 2 cos u. Now, of course, the original question had the curve y equals so many x's, so you need dy by dx in terms of so many x's. So you now need to change this back to 2 cos, and then u from up here is the same as 2x. And there you go. That is what dy by dx is for that particular example. End of question. So let's do a second question. I'll do another one with trig terms involved. I'll use f of x notation. F of x equals the cos of 3x plus pi by 2, for example. Now, a lot of people are put off when they see something like plus pi by 2 here. You don't need to worry about this. Pi by 2 is just a radian measure of angle measurement, and it's just a number. At the moment, we haven't done advanced trigonometry, so you might not be familiar with this sort of notation, but all you need to know is that this thing inside the bracket has got 3x's plus a constant. That is a number. It's actually pi by 2 radians, which is the same as 90 degrees. You don't need to worry about it except to say it's a number. So when you are now differentiating this, what we do is we say let u be the thing inside the bracket, which is that. We're going to need to use du by dx. So you differentiate the 3x, you get 3, and you differentiate pi by 2, which is a number, you get nothing. You also need now to write down, well, okay, we had f of x is equal to cos of, and this thing in the bracket is known as u from now on. So the notation you use will be f dash of x for this. F dash will be equal to, you differentiate cos u with respect to u, and you will get negative sine of u. Now what you do is you work out the final f dash of x. F of x was equal to that, so we're now working out f dash of x. And this is going to be equal to, and here we go, we say dy by du times du by dx. Well, dy by du, that's this thing here. We've differentiated this with respect to u. You get minus sine u. And you multiply it by, I'll put that in a bracket because of the minus sign, du by dx is 3. So you end up with minus 3 sine u. Again, the answer needs to be in terms of x's, so you get minus 3 sine of 3x plus pi by 2. And there's the answer. Okay, let's try number 3. Okay, for number 3, let's go back to the y notation. Y is equal to, and we'll do something such as this. How about e to the power 2x? Okay, in this particular case, you have got a function of a function going on, so you've got a 2x function and you've got an exponential function acting upon that 2x function. So what I would say is let u be equal to the 2x this time. As before, du by dx is equal to 2. And so we can also now say that y is equal to e to the u if you replace the u with the 2x with the u. So we've got this over here, and you need to know what dy by du is. Dy by du is, you differentiate this with respect to u, standard result, it stays the same. So now what we need to do is dy by dx will be equal to dy by du times du by dx. And this is equal to dy by du is e to the u times du by dx is 2. So you end up with 2 e to the u. And then 2 lots of, change the u's back into x's, u is the same as 2x, so you get 2e to the 2x. And there's the answer, and it's as simple as that. Okay, let's try number 4. Okay, another straightforward example. How about something like this? How about y is equal to 1 over e to the 4x? Very common sort of question. Now, before I actually do this one, what I'd be tempted to do is, you certainly don't apply the quotient rule to this. You might think, oh, it's a quotient rule. The top one there isn't really a function of x. I mean, you could write it as x to the power 0 and use the quotient rule and you would get the right answer. But it is not the best way of doing this. The best way of doing this is to write this as y equals e to the minus 4x, like so, because the e to the 4x is on the bottom line. And now use the chain rule, or function of a function, because it's a minus 4x function being acted on by the exponential. So we say let u equal minus 4x, so du by dx is equal to minus 4. We then say y would therefore equal to e to the u, and dy by du will be exactly the same thing from the standard result. So to get dy by dx in this case, you say dy by du multiplied by du by dx. dy by du is e to the u, and you multiply it by, put this in a bracket, the negative 4. And this simplifies to minus 4 lots of e to the u. Change the u's back to x's, minus 4 lots of e to the minus 4x, because u from up here is minus 4x. And there you go, there's dy by dx. I'll do one more of these basic types. Number 5, how about y is equal to log to base e of 2x plus 1. Okay, so you're going to differentiate this. Okay, you've got a 2x plus 1 that's being added on by a log function. So again, you recognise it's like function of a function. So we'll let u equal the thing inside the modulus signs. Du by dx will be equal to 2. And therefore you can say that y is equal to log of u over here. You need to know what dy by du is, and that's going to be 1 over u from the standard result you learned for log differentiation. So dy by dx, let's move this up, dy by dx will be equal to dy by du times du by dx, which is equal to 1 over u, dy by du is 1 over u, times by du by dx is 2. So you end up with 2 over u. Equals, change the u back to x's, so it's 2 over 2x plus 1. And there's your final answer. So there you go. I've done 5 basic examples applying the chain rule to very simple questions where you have got standard derivatives involved in the question.